Welcome to EduNinja. This is an exam concept lesson. Today we are studying A-level geography for CAAE. Our topic is the Hjulström Curve. It helps us connect river velocity with erosion, transport, and deposition. We will break down the diagram first, then apply it to real exam questions. Concept first, then real exam questions. Let's begin. Let us begin with key concept 1, how to read the Hjulström curve. River velocity controls whether sediment is eroded, transported, or deposited. First, look at the axis. The vertical axis shows river velocity. The horizontal axis shows particle size. The curve separates three processes. Above the curve is erosion. In the middle is transport. Below the curve is deposition. Remember, read the particle size first, then compare river velocity with the thresholds. Now focus on erosion. The erosion threshold is high at both ends of the particle size range, but for different reasons. Very fine clay particles can stick together because of cohesion, so the river needs extra energy to break them apart. Very large gravel particles are difficult to move because they are heavy. Sand is easier to erode, so its threshold is lower. This is why the erosion line dips in the middle and rises towards fine clay and coarse gravel. Once sediment is moving, we need to describe transport. In suspension, tiny particles are held within the flow. In saltation, sand-sized particles bounce along the bed. In traction, larger stones roll or slide along the channel floor. These are different transport processes, but the key idea is the same. The river has enough energy to keep the particles moving downstream. Deposition begins when river velocity falls below the settling threshold. The largest and heaviest particles settle first, so gravel is deposited before sand. As the river slows further, finer sand and then silt can settle. Read this from left to right as velocity decreases. Coarse material drops out first, followed by progressively finer sediment. Deposition is therefore controlled by both falling velocity and particle size. For an exam question, use a simple three-step routine. First, identify the particle size. Second, read the river velocity. Third, compare that point with the curve and name the process: erosion, transport, or deposition. For example, if the particle is sand and the river is slowing down, the point moves below the settling threshold, so the correct process is deposition. Always explain the decision using the graph, rather than simply naming a zone. Here is a real exam question on the Hjulström curve. Read the question carefully. Describe how the competence of a river changes as velocity increases. First, locate the particle size on the horizontal axis. Start with the material named in the question, and do not guess from the picture alone. Next, read the river velocity on the vertical axis. Follow the guidelines until the two values meet. Then decide which process is taking place: erosion, transport, or deposition. In this example, sand is moving at a falling velocity, so the correct process is deposition. Remember that transport is shown between the erosion and deposition thresholds. The key exam habit is simple: read the particle size, read the velocity, and then name the process. That three-step routine keeps your answer precise and easy to mark. Here is a second real exam question. This time, compare two sediment sizes at the same river velocity. The river is moving at 20 centimeters per second, and it carries both clay and sand. Start by locating the two particle sizes on the Hjulström curve. Then use the same velocity for both particles. The important point is that the two materials do not behave in the same way. Clay particles are cohesive, so their erosion threshold is high. At 20 centimeters per second, the clay falls below its deposition threshold and is deposited. Sand is different. At the same velocity, it sits in the transport zone, so it remains in motion. In an exam answer, compare the thresholds and explain the role of cohesion. Do not assume that smaller particles are always easier to erode.